Very good day to all lecturers. My name is Rilwan and today I'm going to do my MGPG optimization presentation. So this is what I did for my project. Firstly, there's the refactoring. So what I did was I separated the game manager script that was provided in the game into different classes. Firstly, there's a frame manager which is responsible for instantiating the frames at the start of the game, updating the left neighboring frames of each frames that are being instantiated, and also check when a frame should be respawned, as well as carrying out respawning processes. Secondly is the frame classes, which is applied to every frame prefab, and it's responsible for moving the frame, rotating the sprites within the frame, as well as randomizing the animal sprites whenever it is needed to be randomized. Thirdly, we have the background animals manager. This is basically responsible for moving the oscillating animals at the background, and it's actually responsible for that. Next up, we have the audio manager, which actually plays the audio clip whenever we try to match. We have a particles manager, which plays the particle, triggers the particle effect whenever there's a match or no match. And finally, we have the GUI manager, which actually updates the seconds and the score UI during the gameplay. So the reason why I separated the scripts into new classes is that so each class is more uh, specialized for their own set of functions, so that it will be easier for us to read and also see how the code comes together. So next up, we're moving on to asset optimization. So here are the optimizations that I did: resizing of the game sprites, modifying import settings for audio assets, as well as modifying particle assets. So let me show you what I mean. So here's my Unity project. So you can see that previously the here are the resized sprites. I've actually uh, resized the sprites to be a max size of 64 for each of the small sprites. This is because the previous sprites that were actually provided to us were actually way too big. For example, you can see the formation of this sprite. It is 4167 by 4167, which is way too big for a mobile game. So that was the first optimization that I did that actually brought back up the frame rates. Secondly, secondly, I also modified the import setting for audio assets. So what I mean by this is that when I go over to the audio, there's actually this settings called force to mono, and what basically this helps with is that it um, uses up lesser memory for the game, as it is only one channel compared to stereo. So the third modification for assets is the particle spikes. Whenever I played the game previously, the sprites weren't actually up to speed. So what I did was to actually modify the amount of particles that are generated whenever a particle is being triggered, and it actually brought up the frame rates. So next up, I'll move on to the optimization for the code. So let me just show you the gameplay. So now let's move on to the codes. Alright, so we will go. Let me go through by classes, and I'll go through the optimization as well while referring back to the original code. So basically, here are the steps that I took. So I basically took all the firstly I refactored all the codes relating to the background. So over here we have these variables which are related to the background animals manager. So we have these things here that actually finds the game object and actually sets the vectors where it has to go to. And what I did to that is actually I brought it to the background animals manager. So the optimizations that I did was, instead of having a reference to 3 different game objects, I parented all the 3 background game objects to one, and basically I did the same thing as before, which is to find the distance to go to the left and distance to go to the right. And I also skipped the game object of find, which is actually expensive as a Unity API call. And I also cut down on the number of references I needed. So instead of these 3, I only had 1. So okay, so the background manager, basically every 3 seconds it will change this boolean and it will set active to wherever the boolean is. Then it uses the math f.pingpong to actually move it to the left and to the over time. So let's go over the first script that I refactored to, which is frames manager. So basically we have a few variables here, and I've actually added another list which is called the frame list, and actually stores a list of frame classes, and this actually helps us to reduce the number of get component calls compared to the previous code. So in our wait function, get the frame width, get the main camera distance. This is actually used, this variable is actually used during the raycast, so that you don't have to call on the the camera class all the time. Instead we reference it. So we get the game height, game width. In the left extend, we initialize the list. We get the components of the other managers. And so this is at the start of the game, which is the first frame. So what's going on right here is that we'll, similar to the previous code, we'll actually instantiate the frames from left to right based on the extent. And what I change here is that I've reduced the number of times the frame width is being calculated, because previously in the while loop it's called for this case maybe about 6 or 7 times, but instead I have a boolean to actually call it only once. So after that I add the game object to the game object list, and the frame component of it into the frame script list. So after that I'll update left frames. And what is update left frames? So you'll find out later. In the update function, I've actually put a check hit frame and check respawn frames into here, and actually cut down on the I've actually refactored the code, which is in the update function. Let's see, okay, right over here in the update function, you see that this whole thing I've actually brought it into one function in the frames manager, which is check, hold on, which is handle hit frame if I'm not wrong. Yes, okay. So let me just go through how my code works. So in the update function, it will check whether the frame is being hit, and also check whether the leftmost frame needs to be respawned. So then I've created a function called update left frames. Basically, this function updates the left frame of every frame. So since we have a list just now, the leftmost frame in the list will be the leftmost frame in the scene view, hence it's index 0. So this will not have the left frame, as it is the leftmost frame. So basically I iterate through the whole list You can actually set the left frames, and over here, so this actually allows us to not use the raycast to get the distance between neighbors, and I will show that to you in the frame class. So next up, we have the check respawn frames. So basically, in every frame update, it will check whether the leftmost frame, the game object, the leftmost frame is going past the left extent. If it's true, then we'll bring into this respawn frame function that I've refactored, and which takes in the frame to respawn and will actually respawn this frame. Next up, we have the respawn frame function. So basically, it takes in a frame and it basically respawns it. What it does is, at first, it randomizes the animals within the frame. After that, it sets the position to the frame width, of the end frame, which is the rightmost frame. It will set the transform position, and it will remove it from the list initially and add it back so that it will be added to the back of the list, and it will update the left frames as I've gone through earlier. So every time a frame respawns, it will update the left frames. And the left frames is used to move the get distance between the frames. So we also have check hit frame, which is in every update. So basically, when the player presses on the mouse button, it sends out the raycast, and I've actually changed the math f infinity previously. Let's see, from math f infinity, which is a bit costly, to the main camera distance, and this is actually the distance from the main camera to where the position of the frame prefix will actually be. So what is called? It will call this function handle hit frame. So this handle hit frame takes in this game object. Then it will check whether it is matched or not, whether the frame is mirrored or not. And I've actually used a bool instead of needing to check one by one whether it's a mirrored frame or not, and I will explain that in the frame class. So you'll get the frame component, and if it is a match, update the score, respawn the frame, trigger the particles, and play the sound, the audio. And likewise, if it's not a match. So let's move over to the frame script. Now we have the wait function. We'll get the top, which is the top panel of the frame, the bottom panel of the frame. Initialize some arrays, some transforms, and I'll go through over that in the other functions. So at the start of the game, we want to add all the animal sprites into this top array, top panel array and bottom panel array sprites, so that will reduce the number of get component calls. Actually do it one time in the start function, also the game object as well. Then we'll call on the initialize frame, so that will be, I'll go through that. So in the update function, we want to move the frames to the left as well as rotate the sprites as this is going on. So in the move frame function, as said previously, we have the function called update left frames. So every frame will have a reference to its left frame. So if it has a left frame, which means it's not the leftmost frame, so we use the vector 2.distance to actually get the distance between the leftmost frame and the current frame. We get this distance. If this distance is more than the offset, we will speed it up, else we will bring it to normal speed. Likewise, if it's the leftmost frame, it does have a neighbor, so we'll check if it's going, and we want to make it catch up to the left screen of the left part of the screen if it's the leftmost frame. So if it's more than the game width, the left game width, it will speed it up, or else it will be in normal speed. So we have two functions, randomized frame and initialized frame. So randomized frames will be called in the frames manager previously, and what it does is it is actually to randomize all the sprites within the frame. So we have a random boolean over here, and if it's mirrored, it will set this mirrored boolean, which is reference here, and this will actually be checked by the frame manager to check whether if it's a check or not, instead of using the initial code, which is to actually get all the child and actually see if it's mirrored or not. So using this boolean, we can iterate through all the animal sprites and actually change the sprite using the array that we've made earlier, and this is if it's not mirrored. So we also have a rotate sprite, which will look through all the sprites in the frame and actually rotate them in every frame update. So that's it for the frame script. And also I've optimized the get distance to neighbor. Let me see. Should be yeah, this one, as you can see, instead of doing this raycast thing and also this kind of redundant code to actually check if it's a left neighbor, I've actually used this vector2.distance, which is much more optimized, which actually improve the game performance. So we also have a particle manager which actually triggers the particles whenever there is a match. So basically how this works is that when you start the game, there's already two particles in the game scene, and every time when I trigger the particles, you will basically get the particle system class to actually play the particles, and this is better than instantiating a new particles all the time, as we will be using the particles whenever we need them. Hence we only have one type of each particle in the game. So we also have a UI manager, which I just brought it from the original game manager to a new class so that it will be less cluttered. And I've also implemented this minus score whenever a player does not make a match. So I have an audio manager which actually plays the sound effects based on the boolean that is passed in through this function. And that will be it for my optimization. I hope I have explained through all the sections properly, and thank you for your attention.